Getting this one? And I2 will not be visible for person X. Okay, I think slowly you are, okay, now we'll take these are some problems what I picked up. Okay, now we'll focus on some more problems. Like if a ray is incident on a combination of mirrors, how to trace out the final, the deviation suffered by the ray or any other condition that are put, no, so that has to be worked out here. Okay, read the question now. Find the deviation suffered by the incident ray after 3 successive reflections with the mirror. So there's a mirror M1. First it will strike M1, then M2. So there's the first reflection. Then again, second, again third. Then he's asking the deviation. And what is this? This should be the normal. This line should be normal. Okay, we'll trace out our what can be this? This angle should be 40 because this is the normal. There's a normal. So if you are getting confusion, write it here. There's a normal. Normal to what? Normal to mirror M1. So and we know that this total angle should be how much? Should be 90. So therefore this will be 40. No. So angle of incidence should be quote angle of reflection. After reflection, the ray, I think we have to draw carefully. Huh? In whatever direction, you should not send the reflected ray. So this angle must be quote how much? 50 degrees. So this angle will be 40. And then, so sum of these two angles, 40, 30. So sum of interior angle should be quote exterior angle. This exterior angle should be quote sum of interior angles. So therefore this angle will be 70. Okay, now we'll go for the normal. Getting the normals are very important. Okay, what can be this other angle? This other angle should be 20. Then after reflection, the ray, what will happen to the ray? The ray angle of incidence should be quote angle of reflection. Okay, this angle must be 20 degrees. Then again, we'll produce one more normal. So this angle must be 70 degrees. What can be this angle? Should be 80 degrees. Total sum of all these angles in the triangle should be 180, no? 30 plus until 80. So this angle, how much it will be now? So I think now we are very near to the answer. This angle must be equal to 10 degrees. And finally the ray, so what angle it should move in this direction? 10 degrees. Yeah. Okay, we'll give all this is after 2 reflection. So look at the number of reflections, first, second, third. Okay, the reflections number will indicate. So there's a reflection 1, 2, 3. So this angle, how much it should be? It should be 10 degrees. So this angle should be 80 degrees. He's asking now the deviation. Total deviation suffered by the ray. I think somehow you should be very good in the basic geometry here. So the total deviation should be equal to sum of deviation. at 1, 2, 3. Deviation at 1. See, what is the deviation at 1? The ray wanted to go straight, but it gets reflected by this mirror, no? It gets reflected by mirror. So that then you extend this particular line so that this total will be unreached. This total angle will be unreached. So the ray wanted to further traverse it. So there's the first problem. I'll show all that the resultant deviations. I'll come to this later on. Okay, no. The ray wanted to go straight. Okay, I think it'll be very lengthy. Let me show like this here. So what is this angle will be? 80 degrees. So how much it got deviated? 180 minus 80, 100 degrees. So what is the direction? Should be anti-clockwise. Should be anti-clockwise. Similarly, come for the ray 2. At reflection 2, the ray wanted to go straight. Then finally it got deviated here. So what is the deviation? So this angle is 40 degrees. So there's a deviation will be how much? 140 degrees. So the deviation here is like this. The deviation here is like this, delta 2. There's a ray 2 after reflection, ray 3. I think there's a one best way is what I'm trying to explain. Then again at 3, what conditions will arise? The ray wanted to move like this. So after reflection, now it is moving here. Now this total angle will be 20. What is this will be? 160 degrees. So this 160 degree in what sense? So the total deviation, the sum of this one, the total deviation will be delta 1 plus delta 2 plus delta 3. Delta 1 anti-clockwise, delta 2 clockwise, delta 3 clockwise. Delta 1 will be 80 degrees. Anti-clockwise, delta 2 clockwise, delta 3 will be clockwise. So total will be, this will be 300 minus 80 degrees. 300 minus 80, 220 degrees clockwise. Or 120 degrees anti-clockwise. Able to make it out? So this will be our answer. Now, what is the, how we are to enter? 220 degrees clockwise. This is the net deviation. Okay, now similarly, we'll take the another question related to this. Find the total deviation suffered by the ray after 3 successive reflections from the mirror. Now, the ray is incident on the mirror M1. Let me proceed here now. So after reflection, oh, so this ray after reflection We'll go and strike this. Yeah, 40 degrees. Just wait, this orientation of this. Let me set right it. Huh? Yeah, fine. Because drawing diagram will become little bit easier, because 30 degrees I have to show that smaller angle. Okay, now come for this one. After reflection, the ray, (40 degrees) it will come here. So then we'll take the normal at this point. This is a normal. So what are the angle? So this angle is 40 degrees. The incident angle was 40 degrees. Sorry, this angle was 40 degrees. So this angle will be 40. What about this angle? Will be 50. After find the total deviation suffered by the ray after 3 successive reflections from the mirror. This was the question that is asked for us. So there's a 50 degrees it happened. Okay, then one more reflection it will take place. We'll take this one. So it will be, the ray will come here. So there's a normal. And finally the ray will, okay, there is a deviation. We'll give this one. So this will be 2 arrows. After reflection, 3 arrows. Finally, after reflection, 4 arrows. So number of reflections are there. First reflection, second, third. Are the same similar problem what we had? We had to proceed here. This angle what we have, 30 degrees. How to proceed to the next part of the problem? Whose help you have to take it? Okay, we have to go for this angle, no? This angle is what needed for us. This angle is needed. If you can get this angle, so we know this angle 50 degrees. So you extend this line. You extend this particular line. So as you extend this line, the total, this is 90. This will be 30, 120. So what can be this angle? 90, 30, this will be 60. 60 and this is 40. Under it will be. So this angle will be 80. I think this is a very, very important thing here. No? So after getting this, it will be quite easier. No, this will be 80 means this angle will be 10 degrees. We'll bring the, I'll magnify. Hope we can. Yeah. So what can be this angle? This angle should be 10 degrees. This angle also should be 10 degrees. If this angle is 10 degrees, this should be 80 degrees. This should be 70. If this angle is 70, then this should be how much? 20. Okay, fine. Everything we are able to make it out. So now in the from similar to this, like previous problem, the deviation suffered by 1 clockwise, deviation suffered at 2 anti-clockwise, deviation suffered at 3 anti-clockwise. So the ray, there's an incident ray. After reflection, it will move. The ray wanted to proceed further, but this was after reflection, it will move like this. So this is the deviation, no? 180 minus 80 degrees. So 100 degrees is the deviation. So it is clockwise. Now the after reflection at 1, the ray will proceed here. Now it wanted to traverse straight like this. Then what happens? It get reflected by mirror M2. So this will be the deviation. This will be the deviation, that one. Similarly, after second reflection, the ray what happen will undergo reflection and will move like this here. Then the ray, if the mirror M1 were not there, it would have traversed in this way. It would have continued its straight line path. Because of reflection, it is moving now in green color path along this line. So now this will be the deviation. No, this is not deviation. Again, you have to extend this brown color line. That angle is what you should measure. So like similarly to this, we can I can help you with some set of diagram. The ray 1 extend here. After reflection, it will become like this. So this is the deviation delta 1. So this angle is how much? 80 degrees. So what is the deviation? Delta 1 will be 100 degrees. Similarly, for ray 2, so there's a ray 2. After reflection, it will move like this. So what is this angle? 20 degrees. So what can be this? 160 degrees. So this is the deviation. Now come for the ray 3, reflection at 3. So the ray wanted to go this. After reflection, the ray will move in this direction. So this total angle will be 40 degrees. What is this angle will be? Delta 3. Got the idea now why I'm showing the angles clockwise, anti-clockwise. So here I'll measure clockwise. This delta 1 is clockwise. Delta 2 and 3 is counterclockwise or anti-clockwise. So the net deviation will be equal to delta 1 should be equal to 100. Delta 2 should be equal to 140. Delta 3 should be equal to, this will be, sorry, 160. Delta 3 should be equal to 140. (200 degrees clockwise or 200 degrees counterclockwise. These are some problems which student has to fight with the geometry part. Okay, the complete question is visible. Two numericals, little bit in different conditions is what I brought it.